So let's do one more question like that. So we're given another point, -4, 3, and again we need to find sine, cosine, and tangent of an angle theta such that this point is on its terminal side. So point -4, 3 is somewhere over here in the second quadrant, right? Well, that means that the terminal side of my angle theta is this one, and angle theta itself opens this far. So angle theta terminates in the second quadrant. Let's find its function values. By the way, right away you can see that this angle would not fit in a right triangle, but good news, we have definitions that still allow us to find its function values. So sine is y over r. Before I move on, I need to find r, right? I have the y coordinate, 3, but I need to find r. Okay, so I'm using equation x squared plus y squared equals r squared to find r. X is -4. Don't forget that when you square a number, square a negative number, put it inside the parentheses and it's going to be -4 times -4, so it's going to be +16, so it becomes positive every time you square a negative number. Y squared is 3 squared, so that's +9. 16 plus 9, that's 25, equals r squared. And just so that we get used to remembering that after this step we always get positive and negative value, I'm still gonna write it even though I know that r is always positive. So it's plus or minus 5, the solutions to this equation, but we are picking the positive sign since radius is positive. Okay, so it's +5. I'm going to put it here in the denominator, so 3 over 5. That's it. Sine of theta is 3 over 5. Cosine of theta is x over r. X is -4. And r is 5. So it's -4 over 5. And now we're starting to see that function values can be positive or negative. Right? We got positive sine, but negative cosine. And in general, sines, positive, negative, will depend on where that angle terminates. And then how about tangent? Tangent is y over x. Y is 3. X is -4, right? Usually we don't keep negative sign in the denominator, so I'll just put it in the front. -3 over 4. By the way, yeah, with negative sign, you can either keep it with the numerator or put it in the front. Both are good. So tangent has also a negative value for this angle theta. Now, you might be wondering and having question, still, we have those definitions, but how do they work? Because when we developed these definitions, we did use the right triangle, correct? Then how does it work here? Because angle theta cannot be fit into the right triangle. Well, that's still true. It cannot be put in the right triangle. However, there's always going to be a right triangle and another angle related to the given angle, such that that angle can be in the right triangle. And in this case, that right triangle is here. And as we can see, this right triangle has sides that correspond to the numbers that we used. Here's the hypotenuse, it's the radius, right? 5 units. This side, this leg is 3 units. This side is 4 units. So the angle that we could use to actually find answer for our angle theta is here, angle that fits in the triangle. And that is a special angle. It's actually being denoted by the same letter, but with a little prime sign. So it's theta prime. It's called reference angle. Reference angle. We'll talk about reference angle more in the future, but I just wanted to point out here that yes, while we can't really put theta inside the triangle, well, there is a related angle, or it's called reference angle, that can be put, and that's basically why those definitions are still working for angle theta. Let's do one more example. This time we have 0.03. Let's plot it. 0.03 is on the y-axis, right here. 0, 0, 3. Okay, well then this must be the terminal side of my angle theta, and then the angle theta is this one. Well, you probably recognize this angle, right? It's a 90-degree angle, but for now let's just call it theta. Now finding sine, cosine, and tangent will be quick and easy, just because we don't even have to do extra steps for finding radius. So what is the radius here? It's going to be easy to determine. Radius is this distance, right, from the origin to that point, and we can see right away that it's 3 units. Okay, so we're good to go. Sine is y over r, y coordinate is 3, radius is 3, so that's going to be 1. Now, cosine, x over r, x is 0, x coordinate, and then over 3. Now 0 divided by any number is always 0. The result is always 0, so cosine is 0, and then tangent is y over x. So y coordinate is 3, and the x coordinate is 0. When we're dividing by 0, that is an undefined operation, so there is no answer to that. It's undefined, so I'll say is undefined. Right, so 0 divided by number is 0. Number divided by 0 is undefined. Try to keep that straight. So what did we get here? We got results for angle theta, but we said that angle theta equals 90 degrees. So that means that we were able to determine sine, cosine, and tangent of 90-degree angle. So sine of a 90-degree angle is 1, cosine of 90 degrees is 0, and tangent of 90-degree angle is undefined. So, which means that there is no tangent value for a 90-degree angle. Now, you may say that, well, what if that point was different? Would we get same answers? So let's think. So if that point was, let's say, 0, 10, so it's like way higher. What does that mean? Well, it means that the radius was going to be not 3 but 10. But as we put everything here into the definitions of those functions, we'll get, well, y is 10, radius is 10, we still get 1, x is still 0, 0 over 10 is 0, and then y over x, 10 over 0 is still undefined, right? So it doesn't matter how high or low I place that point, I still get same results. So it means that, well, those function values for a 90-degree angle are always the same. And it's going to be a good time to talk about the reciprocal function values for a 90-degree angle. Since I have space here, I'll write it to the left. So sine, the reciprocal of sine is cosecant. And I'll just have to take reciprocal of 1, right, which is, again, 1. Now cosine, its reciprocal is secant. Now, what is the reciprocal of 0? You know what? It's probably going to be easier if we look up here. So here's cosine 0 over 3, but reciprocal of that will be 3 over 0, right? So reciprocal 3 over 0, and what is 3 over 0? That's going to be undefined, right? And then finally tangent, and we have its reciprocal cotangent of 90-degree angle. Here we know it's undefined, but let's look up here. Tangent is 3 over 0. Well, reciprocal will be 0 over 3. What is 0 over 3? 0 over 3 is 0, so equals 0. So here we go. We have 6 function values for a 90-degree angle. And finally, our last example is 0.40. That's on the terminal side of angle theta, and we need to find function values for that angle. So 0.40 is here. 40, it's on the x-axis. and it's on the terminal side of angle theta. So I have to construct terminal side. What is this angle? So looks like its terminal side, I don't know if you can see it, so its terminal side is the same as its initial side. Well, that means that, well, one of the cases for that to happen is that when we haven't even done any rotation, and if we haven't done any rotation, it's going to be 0-degree angle, right? So it means that this example will allow us to find, well, let's do 6 function values for 0-degree angle. So sine of 0-degree angle. And by the way, idea is the same as in the previous example. It doesn't matter that I'm using 0.40. I can put it further away or closer to the origin. All the ratios will end up equal same thing. So sine is y over r. Now y is the y coordinate, that is 0. And r, well, r is this distance, r. And obviously it's 4 units, right? R equals 4, 0 over 4. That is 0. Cosine of 0-degree angle is x over r. It's 4 over 4, that is 1. Tangent, y over x, that is 0 over 4, that's 0. 0 over 4, okay, 0. And let's do the reciprocal functions. So cosecant, which is reciprocal of sine, we'll get, I'll just flip, 0 over 4, I'll flip it and I'll get 4 over 0. That is undefined. Secant, which is reciprocal of cosine. So here I have 4 over 4 or 1. Well, reciprocal of 1 is 1. That was quick and easy. And then finally tangent, and it's reciprocal, so cotangent. Tangent is 0 over 4. Cotangent will be 4 over 0. And that is undefined. So now we have 6 function values for a 0-degree angle. By the way, could we say that we got this result, this kind of situation, if we rotated all the way around and came back? That would be 360-degree angle, right? And we would look at the exactly same picture at the end, like this one. That means that the function values for 360-degree angle are exactly the same or have exactly the same values. And it's just, a good observation at this point, but we'll talk more about things like that in the future. So we'll learn how to find function values for pretty much any angle if we know a point that lies on the terminal side of that angle.